natural log of 2x minus 3 equals 5. So you can rewrite this as an exponential. In this class, I typically start to just do this e to both sides because this e and natural log cancel each other out. So we've got 2x minus 3 equals e to the 5th power. And then you just add the 3, so you got 2x equals e to the 5th plus 3, because it doesn't look like it, but e to the 5th is a number. E is just 2.74 or whatever. So, and then you divide by 2. So x equals e to the 5th plus 3 all over 2, which is your answer. I don't really, yeah, it's actually a number. We could type it into our calculator and get a decimal for it if we needed to. Sometimes they put this stuff on the calculator inactive and you're supposed to leave your answer like that. So we'll just do that here. Okay, any questions? All right, so we have taken derivatives of exponentials where we have a base of e, but we have not taken the derivative of an exponential where we have a base other than e. I'll let you copy this down. So when we take the derivative of something raised to a power, a number raised to a power, we're going to do, it's pretty much like the derivative of the exponential, because the derivative of a to the x is a to the x, except when you have a base of anything besides e, you have to multiply it by the natural log of that number. So for example here, for example 3, we're finding the derivative of 3 to the x power. So whenever you take the derivative of this, you're going to have f prime of x equals, the derivative of 3 to the x is 3 to the x, but anytime you have a base other than e, you have to multiply that by the natural log of that base, so natural log of 3. You can leave it like this. You might see it written natural log of 3 times 3 to the x power. But either of those is fine. So it's basically the same, except we have to remember to multiply it by the natural log of whatever the base is. So let's do a couple that are a little more difficult. Give me a second to write those down. Here, y equals 2 to the 3x. So this is a pretty basic problem, but we are going to have to use a chain rule here. So we're going to have dy dx. The derivative of 2 to the 3x is 2 to the 3x. But we have to multiply by the derivative of that 3x. And what is the derivative of the 3x? Just a 3. And because our base is not e, we have to multiply it by the natural log of 2. And you pretty much leave your answer like that. Sometimes they will put the 3 natural log of 2 first because that's actually a number. 2 to the 3x. But that is pretty much it for this. Okay, questions on that? All right, for example 5, what do we have to do on example 5? It will have a chain rule. It will also have something else. You got to do a product rule because you have two things that are multiplied together here. And on that second part of our product rule, we're going to have, on this taking the derivative of 5 to the negative 2x, we have to use a chain rule on that as well. So when we take the derivative of this, we have to do x times the derivative of 5 to the negative 2x. And so with exponentials, I always know that the derivative of an exponential is itself. It might have some other stuff with it, but it is itself. So it's going to be 5 to the negative 2x times, we have to take the derivative of the exponent, negative 2x, which is going to give us negative 2. And then, because our base is not e here, we have to do natural log of 5. Okay, so I always do this part first. I do rewrite it exactly the same because I know that exponentials are their own inverses. But then take the derivative of the exponent, because you're going to do that even if the base is e. And then on the end, if I have a natural log of 5, I just throw that in there. So if you kind of get yourself an order of work to do, that will help. Now that is just the derivative of 5 minus 2x. We still have to finish the chain rule here. So we have to have plus 5 to the negative 2x times the derivative of x, which is 1. So if you look here, let's make that green. We've got f, and right here is our f prime. Right here is our g prime, and here is our g. So we can see we've done the whole product rule there. So they will probably, I bet, factor out 5 to the negative 2x because it is in both terms. So that will leave you with a negative 2x natural log of 5 plus 1, if you do that. And you may even see them write the answer like this. They'll probably put 1 minus 2x natural log of 5. And they may do this over 5 to the 2x. Since that has that negative exponent for your exponential there, you could move it to the bottom.
So would you have to, oh, wait,
Okay. Okay, questions on that one?
Wait, why did you rewrite it like that?
Now, if it is free response, you can leave it here, you can leave it here, anyway. But if it's multiple choice, sometimes they don't like to leave those negative exponents like that, so they may move this 5 to the 2x down to the bottom of the fraction, so that you don't have negative exponents. So you might see it show up like that. Okay, questions? Yes. It is multiplied by the 5 to the negative 2x, but what I did is I factored out that 5 to the negative 2x, so it was pulled out front. You know, if it's free response, you don't have to do that. You could just leave it. You could leave it, you know, like this. You could have negative 2x natural log of 5 times 5 to the negative 2x plus 5 to the negative 2x. So you could just leave it like that. If it's free response, that'd be perfectly fine. Okay. All right. Okay. Now, we've already done exponentials. So write this down if you want, but you don't necessarily have to. When we take the derivative of e to the u, our derivative is just e to the u, but we have to do a chain rule for those. And we've done these a little bit already. So I'll give you a second to copy those down. Okay, so for example 6, the derivative of e to the 3x minus 5 is e to the 3x minus 5. But if your exponent is anything besides the x, you have to multiply that by the derivative of the exponent. So in this case, that would be 3. All right, so you'll probably write that with the 3 out front, 3e to the 3x minus 5. Now let me give you one thing to think about here. If our base is anything other than e, like if that was 2 to the 3x minus 5, we'd have to multiply by a natural log of 2 on the end, right? If you think of that rule, if I did that here, I'd multiply by a natural log of e. what is natural log of e? All right, let's think about it. Let's do this. This means e to some power equals e. All right, yeah. This is log base e of e equals something, right? So this is e raised to some power equals the e that we have right here. Well, what's the only number that can go there? It's 1, right? So natural log of e is 1. So you can think about these problems that they're just the same as the other rule that we had where we had to multiply by natural log of 2 or natural log of 3 or natural log of 10 or whatever that was. But natural log of e is just 1, so that's why we've left it off this whole time, because it doesn't really change anything. Yeah. So the rule for the other ones does apply here. It's just not really necessary to put that natural log of e because it equals 1. Okay. All right, number 7, we've got the derivative of e to the negative 5 over x squared. Now, I would do a little bit of work on this before I take the derivative, because taking the derivative of negative 5 over x squared requires a quotient rule, and I really don't want to have to do the quotient rule. So what I can do instead is I can say that this is the derivative of e to the negative 5x to the negative 2. So rather than have that x squared in the denominator of that fraction, I can just move it up to the top and give it a negative exponent. And now I don't have to take the derivative using the quotient rule for that part. So I'm going to take the derivative of e to the negative 5x to the negative 2, and that is e to the negative 5x to the negative 2. But we must use a chain rule here. So I've got to take the derivative of negative 5x to the negative 2. So I've got positive 10x to the negative 3. Okay, so for response you can stop here, but you got a lot of negative exponents there, and a lot of times they don't like to leave those negative exponents. So there's lots of ways you might see this happen. Everything has a negative exponent except for the 10. So they might do this, they might leave that 10 on top, and that e to the negative 5x to the negative 2, they might move it to the bottom, e to the positive 5x to the negative 2, that's a little confusing there, and then x to the third, and then they might write it like this, they might write that 5x to the negative 2 back to the 5 over x squared. Okay, questions on that one? All right. Let's skip that. All right, let's do one that's implicit differentiation. And we'll be done here. So we've got e to the xy plus 10x minus 3y squared equals 10, and we're finding dy dx. This 10x is not difficult. The 3y squared is not difficult. The 10 is easy. But this e to the x is going to give you some problems. So when we take the derivative of e to the x, the derivative is, or e to the xy, it is e to the xy. Right? But then we have to multiply by the derivative of xy. And what do we have to use to take the derivative of xy? Product rule. So that's going to be x times the derivative of y, which is dy dx, plus y times the derivative of x, which is 1. Okay, so that, all of that stuff there, that's our derivative of e to the xy. Then we take the derivative of 10x, which is just going to give us plus 10. And we're going to take the derivative of negative 3y squared, which is going to give us negative 6y dy dx. And it equals 0. Okay, so we've got to get the dy dx's together, but this right here gives us trouble because we've got this e to the xy times this stuff here. So what we need to do first is distribute our e to the xy. So we're going to have x times e to the xy times dy dx plus y times e to the xy plus 10 minus 6y dy dx equals 0. And now we have these things separated out where we can get to this dy here, and we can move the other stuff over to the other side. So you'll have dy dx times x e to the xy minus 6y. And that will equal negative 10 and negative y to the times e to the xy. And then you'll divide, so your dy dx will equal negative 10 minus y e to the xy over x e to the xy minus 6y. Or there's a good chance you'll see this written like this. They'll probably pull that negative from the numerator out front and write it as 10 plus y e to the xy over x e to the xy minus 6y. If it's free response, don't do that. You might mess up. Just leave it. But sometimes multiple choice, they'll do things like that. All right, questions? All right, I'm going to go ahead. We're not going to do it right now because we're going to do our warm-up and we're going to check our homework and things like that before we take our quiz. I'm going to go ahead and give you the questions from the packet that will be your homework for tonight. So, let me flip there. It will be, right, it will be, this is all from that packet, page 345. You will do, let's do 29 through 51 odd. And then we do a couple that have those other bases. They are on page 354. And let's do 29 through 34. There. So that'll be your time after you get done.